So this is about coming up with a gold standard for binary C. And that, of course, would be beautiful. And I'm pretty sure you all have looked into the code so far, and you've realized, oh gosh, there are many, many, many options and capabilities. And so even when you're a new user, or maybe if you're an experienced user, maybe if you're a God user, maybe except for Rob, then you're easily overwhelmed with all these options. So you ask yourself, so which option should I use, in particular for the problem that you have? And for example, also what are the best calibrations that there are in the code and in the options? How up to date are these choices? And is there maybe some documentation on the physics? So not necessarily on the numerics and how things are done, but a bit more on the physics, so that you can decide what you want to use. So I hope that maybe we can come up with a way to define a gold standard here that would then, to the best of our knowledge, answer these kind of questions. And of course, this can never be updated, so we will always be a bit outdated, but still we can try to do the best that is possible. So to summarize in essentially one sentence, can we come up with a little statement like use gold standard and set it to true, and then binary C would automatically load a certain set of settings and options, enable capabilities, make some choices for you, such that once you have enabled this, you will get quite accurate, or as accurate as possible, results by running binary C out of the box. This is, of course, a huge and a massive task, and I'm pretty sure that we're not going to be able to find standards for all the different options that there are. But maybe we can at least try to go as far as possible to have maybe a binary C that out of the box can predict type 1a supernova rates, can predict the rates of X-ray binaries, can maybe look into different supernova types, how many mergers would occur, maybe also going into the direction of gravitational wave sources, and so on and so forth. And there's, of course, some common physics that one has to think about, and I just listed a few items here, and there are many more probably that we want to add, and maybe we can add this just sort of in a little discussion, and then I'm going to add these things as we discuss it to the slide, and we can take it from here. So what I briefly presented yesterday was on stellar winds, and this was my attempt, as I said at the time, to come up maybe with a prescription for stellar winds that could be such a gold standard on this kind of physics. But then I know, for example, we would need to have some kind of model for pulsational pan-stability supernovae, for pan-stability supernova itself. So we saw already from David and Gio how you can maybe come up with a Rorschach overflow scheme that is maybe fast, stable, and reliable. And then the question comes naturally to mind is what to do with non-conservative mass transfer. We can think about wind-Rorschach overflow. We can think about the critical mass ratios for common envelope evolution, for mergers. And certainly some of these mass ratios really need urgent revision, because some of them are just completely, say, not up to date anymore. And they predict just wrong numbers for certain types of objects. So here I'm thinking, for example, of blue straggler stars. Some of these numbers, for example, what kind of, how many blue stragglers of what kind you should get in all stellar populations. This is something that critically depends on these mass ratios, and it is not coherent with current observations. And I think we already know kind of which mass ratio we need to switch a bit or to tune a bit, and then we can get much, much better results. For some reason, I have not listed common envelope evolution here. But obviously this is implicitly already on the list. But we have to think about, for example, the compact remnant masses, about nucleosynthesis choices. Maybe you want to add magnitudes to binary C so that it can automatically come up with, I don't know, standard Johnson magnitude systems. And I'm sure there are going to be many, many more points on this list.
They're already there.
Yeah, I know that there are several magnitudes in binary C, but some of them really give funny and spurious results, which I wouldn't believe.
That's
so we
right.
would need to have to review these things. And this is maybe how I want to suggest how we can maybe proceed from here. So maybe we can first of all come up with a list of different kind of physics that we would like to have a gold standard for. And then maybe we can distribute these tasks and find people who know binary C and can maybe oversee some of these options, that we can find a gold standard that we can put into the code. And even more so, where we can maybe put a very, very quick documentation on why have these gold standards been chosen. Because that would give other people then immediately the chance to see, okay, so this is, I don't know, the alpha value of this common envelope prescription is set to, I don't know, 0.25685, whatever, comes from paper XYZ. I'm sure we should maybe brainstorm a little bit now and add maybe more pieces to the previous list on the slide before. Maybe we can even set some goals now, in the sense of, I don't know, whenever Rob is going to have the next binary C workshop, that we can then take the next steps and maybe implement some of these things. So if I go back maybe to the slide and we can brainstorm on this, or maybe we can brainstorm on the whole general idea whether this actually makes sense or not. And if we can decide that we maybe want to have such a thing, then maybe we can think about of all the different options. So I'm open to your ideas, or whether you feel this is actually something that is needed, or maybe you feel this is probably not needed at all. Some open opinions here.
I think it's a good idea. I know other populations in Cisco have stuff like it. Well, maybe not a specific like this mode you can enable or disable, but at least all the default values have been calibrated on observations. So I think that is something that could be useful to have here as well.
So to some extent, the TBSE file has defaults in it which are like that.
Yeah.
And there are references to most of them from a lot of them are from the class paper, which has all the references.
Yeah, I think that these default lists would be the starting point for that. I don't know if everything.
So, yeah, that would be good, of course. I mean, if you can, for example, take the TBSE script and have these options automatically sort of built in binary C to say use gold standard, and this is the gold standard that TBSE would use by default. I mean, that would be a good starting point, and then we can probably get on these things.
What I'd recommend, and well, one technical point, there is a function, there is now one function which resets the preferences, and so all the defaults are set in there. What we should do is have a function which sets, say, the gold standard, whatever that is, but we should also have gold standards that are numbered or dated or something, kind of like Mesa has releases or we have releases. We should do it like that, because then we can say, well, what does the gold standard of last year do compared to the gold standard of this year, and so on. So we can actually monitor then the progress. However, because we have a set preferences function, that's really easy to do now. So it's much easier than it used to be. So I think that is, so it's technically very, very easy to do. The justification of each parameter is going to be quite a lot of work.
Yeah,
that's why I think you're absolutely right. We have to distribute this.
I have two comments. I don't know how useful they're going to be, but one is first, when you have some physics that you don't want to include every time, but often, I don't know, well, if something you have in your TBSC default list is set by default to not implemented or not there, not used, and you set it to used, and you have several prescriptions for that. Do you pick a default prescription, or do you have to specify one by?
At the moment, most of the prescriptions are either off or a stop prescription. So you'd have to specify which one you want.
Maybe we should at least tell people which one in that case.
So that's easy.
But why wouldn't these just be the default binary C?
Yeah, you may not want to include all the physical phenomena at the same time by default. But I don't know, like the other thing I have in mind that I don't really.
I think you do, and I think you should disable them if you don't want it. I think it's also able to default.
But it is an important question, I think, because
I don't know. For instance, for single star models, you may want to not put any thermohaline mixing in there, but still have something that tells you if you were to put thermohaline, use Langer and not Spreu, or the opposite, whatever. And well, that's part of the gold standard, but that's not that standard setup you want to have without being part of every default run. That's what I meant.
Why would you not want it
switched on?
if you think it's more physically correct?
Yeah, I think if it should
Computation
be the
time, it's useless in most stars. These kind of considerations. It actually is useless in most stars. So.
Well, something minor.
Yeah, so I think there would be a valid point to maybe sometimes disable some options if you want to have binary C also to be really fast, right? So this could well be within the gold standard kind of definition.
There's no reason why, for example, when you run binary C, you can't say, I want the gold standard and these things. So you could then disable it after that. That could be done. And I could change the way, say, the binary grid works so that it would set the gold standard first. In fact, that's easy to do because binary grid already does that for some of the parameters. It makes sure they go first.
Yeah.
And then you can override it with all the things you set. Sure. So that's very easy.
use standard and then disable one of the things that you don't care about.
Yeah.
And I think on
So
default
that's
it should be on.
Okay.
That's easy to do. Yeah.
And another thing
That would be a good idea.
that was confusing to me when I first saw binary C results, it was actually through Tom's visual interface. It's the randomness of the supernova kicks. I was really confused that running twice the exact same run would give me different results, to the point that what you have in the end left is different. Maybe randomness should not be part of the gold standard.
No, I think
Or
it's no. Yeah, it should.
You can turn that off by specifying the random number seed.
That's actually what I want to do now.
Yeah, I thought of this option there.
That's
Well,
trivial to do. So
Yeah, but we should. I think the gold standard should have, exactly reproducible results.
Oh,
just
sure, but
for testing purposes.
seems-
when
that's,
you-
but that
Seems
is
like
very
it's
Testing purpose.
It seems like a thing that shouldn't be enabled by default, but if you want to compare
Yes,
it, then
that's
you
what
should
I mean.
use the
Yeah.
CC.
something like
But
that.
I think we're confusing two issues here. You're saying this is a test case and it should work like this. That's a
Yeah,
a technical thing. The gold standard is talking about a physics thing, and that should have random kicks because that's what they are. So, but for numerical testing, yes, you disable it. Yeah, that's easy.
Yeah, so I would agree with Rob here. So I think the gold standard should be gold in the sense of primarily in accuracy to physics.
Yeah.
And then, of course, still it needs to be fast. So if some Roche overflow prescription, for example, might be just a bit more accurate, but then it takes, 10 times longer to compute one binary, then it's probably not worth it. But for this randomness, I think these kicks are an integral part, for example, nowadays of the prediction for these black hole, neutron star mergers, and so on. So this should really be in the gold standard, I think. So I'm going to put kicks actually now onto the list because this is obviously important.
So one thing I can do is for every choice of standard, I can run the population ensemble to generate these statistics for a starburst very easily. I mean, the code's there and that just works. And that will already give you your black hole kick rate pretty trivially. And I have models set up for that will allow you to estimate the Milky Way, for example, and very fast. Or at least it's very fast if you assume everything's solar mentalistic. If you vary the mentalistic, it gets a bit messy. But solar's roughly right for most of the Milky Way, so that's okay. So that we can do. And then that'll give us numbers that we can just test to solar neighborhood. And maybe to Gaia as well. Because Gaia will give us lots of numbers. But I think comparing to observations is going to be a bit of a difficult task in some cases. So you've got big selection effects on many things. And of course, we don't have those in the code. They depend on each survey, so it's hard.
Yeah, I think the difficulty here is defining what is the best thing to use based on observable.
Does it make sense to go through the list that Fabian is showing right now and discuss one-to-one, or you think this is not for now? An example, the third one that Fabian is showing, which is mass transfer rate, stability, non-conservative. This, going back, this goes exactly to what I was mentioning on the first day, pretty much mentioning Fabian's work at 2015 with binary C, where he calibrated mass transfer rate, mass accretion rate, so the beta parameter of how much is accreted. This could be calibration that the gold standards should reproduce if we think that that's how it should go. That's an example. If Mathieu is here, supernova kicks were important in his work too. So we can go one-to-one, or what do you think? What's the best way to think of that?
So we probably don't have enough time to discuss really each individual point. But I think there's a lot of so brain power here in this group. So both physically present in Surrey and also connected on the internet. That maybe we can distribute some of these things, and then these people can think about, okay, what is maybe worthwhile here for a gold standard? What could be done? And then we can reconvene at some point later and sort of
yeah, that sounds good.
Discuss what people came up with for the different things, and then we can tell Rob essentially, okay, so this could be an interesting gold standard, and we can try out and see whether this could, whether this would work maybe.
Sounds good.
Sure.
Yeah, on that topic, I've been doing some research about mass transfer stability recently. So I already have some results of detailed modeling on that, so I'd be happy to sort of find a suitable gold standard in that area as well. Working on it anyway, so.
Mm-hmm. Yeah, that's ideal. I mean, that's exactly what we need. I mean, there's so many people working on so many different aspects that I'm sure that we're going to find someone who knows the ins and outs of several parts quite well. So that would be great. Yeah.
Cool. I'll write myself down for that.
So maybe what we can do to get this started, I mean, this is only a list of suggestions, but everyone can have a look at this list, and I'm going to send Rob the updated slides so that you can put the PDFs maybe somewhere where everyone can access it. And then the individual people could, for example, send a mail to Rob or to a larger mailing list, I don't know.
Mm-hmm.
I can, for example, take care of this and this part of physics. And this could be, of course, stuff that is not on this list yet. And I could come up with maybe some gold standards or some ideas of what could be a default choice in binary C for whatever you're interested in.
Would it make sense to put a wiki page on the GitLab server that everyone has access to?
Yeah, that sounds great. Yeah, that sounds great. Yeah.
I can do.
Shouldn't the IMFs be on this slide?
Yeah, period.
Say that more loudly.
Shouldn't the IMF be on this slide?
Oh yeah, it should be.
And a
You know,
period.
I've compiled this list of things really quickly, and
Basically, yeah.
That's a shoot.
You complain about her.
Oh well.
By the way, yeah. Do you have Mesa on your computer?
No, I don't.
Okay.
So links.
All right, I put a page on the wiki, which I think you can all edit.
Mhm. Yeah, so that could be a good homework for everyone to go to this wiki page and maybe put your name with a few things or one thing where you feel like you could really make good suggestions, and then we can distribute this gold standard idea to a few people or to many people hopefully. Then we have to take it from there. maybe, I don't know, maybe we can organize another Zoom session however this works best, and then have a brief discussion for the different points and maybe figure out in which areas we still need more expertise or we need to do a bit more research. Then in the end, hopefully we can have a gold standard in binary C. That's sort of, if we have a student, for example, someone wants to do a little project, we can just give the code and say, well, enable the gold standards, and then you'll have something that makes sense. So that would be the...
Would it be a nice that if we have the gold standards that we upload some of the some results of populations, something that Rob can do of rates, for example, and host it on a website?
Yeah, so that is maybe the far-reaching aim in the end. Of course, we could compile a document saying we have chosen, I don't know, a few gold standards, and then we can show predictions for different things that we are interested in.
Mm-hmm.
This could be rates for gravitational wave events. This could be rates for supernovae, for just standard mergers, for novae, for whatever things we are interested in. It's probably a good idea. But this is sort of the next step, I guess.
Yeah. But this would
and
be.
I know that Rob already has, whenever he's running his code, right, he's producing these hundreds of predictions for the populations. So that would be also a nice way, maybe, to take some of those and convert it into something with, in relation to the gold standards.
Yeah.
Well, this sounds great. So I hope that we can also get Mathieu into the loop. I'm not sure that he's online at the moment. But I'm sure that he has a lot of things to add for the kicks, because he has worked on this with binary C for quite some time. Yeah, and maybe we can make people aware that are not yet here, that are not here today, of these kind of ideas for the gold standards, and maybe they can also add some ideas. Great. So I hope this is sort of a kickstart to this whole thing. And then I guess in 1 year time, we can see what has happened.
Nice.
Yeah, that's very good. Yeah. I mean, I'm very happy to assign people to different things because I know what everybody does, but it's better if you volunteer.
I volunteer for something.
Sure. I mean, Rob can always volunteer people. He has a really good overview of who's doing what and who could probably, with a minimum effort, contribute something that is going to be really important.
I should warn you. I mean, there are some things on this list for which there are very, very few or very poor constraints.
I understand this. This is fine, but it's probably also good then in the gold standard kind of documentation to say, well, we don't know and we couldn't find any good references or whatsoever. So this would also be a nice document to look into, to figure out, okay, so where could one maybe make some good progress?
I'm really looking at things, even wind Roche-Lobe overflow, there are, as far as I know, 0 observational constraints on that.
That is true. This would probably also would be on my list, rather on the lower end of the importance here.
Well, for some systems, it could be very important. So it's.
I know.
Yeah, we just don't know. So it's a problem.
I have a small question before I volunteer for something I know nothing about. What do you mean with magnitudes in that list?
Oh, I mean photometric magnitudes. Maybe I should.
So look at observations of binary systems and see how that matches what we predict.
Yeah. For example, imagine you want to make a color magnitude diagram with binary C.
But you can.
I know you can, and but then there's so many different options. I believe, at least last time I looked into this.
Are there?
Yeah, I think there are a couple of options that you can pick from. Essentially, JJ's work. There's probably some kind of port from his
Yes, it is.
Into binary C.
The issue I have with that is I have no real way of testing it, and that's what we can do with. I don't know what's in Maser at the moment for colors, because they predict. There's a module in Maser for predicting colors. If we can effective temperature, luminosity, and log G, or 2 plus 3, to a color, then
Okay. Count me as a volunteer on that thing.
Okay.
I can do with help.
so the code at the moment, I can show you how it works. The code at the moment has Kurt's colors in, which I think are the most trustworthy, but it has others that are converted from that. So it also has, I think, Hubble colors, Hubble filters as well. But I'm not sure I trust them. And one word of warning with the magnitudes, it also has Gaia magnitudes. However, those are converted from the others using the variant that Gaia uses. So I don't want to do that. Yeah, well, that's how they recommend to do it. And until recently, that was the only way to do it because the past bands weren't published because they were private. They belonged to the company that designed the filters, and nobody knew. So, except for 2 or 3 people in the project, so that's why all the papers are Geordie et al. Because they are the only people that knew how to do it. That's no longer true. You can now download some of the data for that, which is good. So, but then, if we're going to do it that way, we have to construct spectra, which we're not going to do. So I think that's beyond what we really want to do, unless that's something somebody feels we should do. Do we want to construct spectra and link our models to spectra and then construct?
Well, probably not. This is maybe an overkill.
Other people do it, so if there are libraries we could use to do it, then we would. But,
well, that's true. If there are already libraries, then probably we can just go ahead. What I actually with the MESA isochrones, I think people they produce, and also with the parsec models, right? You guys have huge libraries, and somehow you compute all these photometry data points. So maybe one can just use more or less some of their techniques.
that would be good. But I can show you how we do it now. And it's not very hard. It's just a sort of formula. So.
All right, good. So I think think about this idea, let it sink a bit, and then maybe everyone can stand up and say what they can do to get this going, and then we take it from there.